This is Unit 7, Target 3 and 4, which uses the Pythagorean theorem and the distance formula to find distance. Specifically for this video, I'm going to be looking at Target 4, which is the Pythagorean theorem. To use the Pythagorean theorem, I have to know a little bit of vocabulary. In every right triangle, there's a right angle, two legs, and a hypotenuse. The legs are always the two shorter sides in the right triangle. The hypotenuse is always the longest side in the right triangle. The hypotenuse is also always across from the right angle. So you need to know which one's the hypotenuse no matter what when you're doing the Pythagorean theorem. The Pythagorean theorem, states what's in this blue box. This is the technical definition. The sum of the squares of the legs of a right triangle equals the sum of the square of the hypotenuse. Well, sum means addition. So the sum of the squares of the legs. So if I add the squares of the legs, so if I take the leg values and I square them and I add them together, that's going to equal the hypotenuse squared. A lot of times we ignore those words and we just go straight to the shortcut, which is what our theorem says in our geometry textbook. If a triangle is a right triangle, then a squared plus b squared equals c squared. But again, the a and the b represent the legs of the right triangle, and c represents the hypotenuse. So a squared plus b squared is leg squared plus leg squared equals hypotenuse squared. Here are two examples of working through the Pythagorean theorem to find the value of x. I'm going to start with the problem on the left. Remember, I have to set it up so that the leg squared plus leg squared is equal to hypotenuse squared. So 7 squared and x squared, because 7 and x are both legs of the right triangle. The hypotenuse is equal to 9, so that's going to equal 9 squared. The hypotenuse is always by itself. The hypotenuse is always either on the left or the right by itself. Then I'm going to solve this problem. So 7 squared is 49 plus x squared is equal to 9 squared, and 9 squared is 81. I can subtract 49 on both sides of the problem, and x squared will equal 32. To find x, when we have a squared, we'll take a square root. And so x equals the square root of 32. Now with my calculator, I can find out the decimal that goes with the square root of 32 is going to be 5 point something. The square root of 32 is approximately 5.66, which is good to know as the number value, see where it's at. But what we also learned in class is how to simplify the square root. So from here, I could say that x is equal to something times something for 32. So square root of 16 times square root of 2. The square root of 16 reduces to 4. And so 4 root 2 is the exact answer. So I have to be careful when I do the problems on whether or not I set the x on the left side of the equation with the other leg, or whether x is the hypotenuse. For the second equation, x is the hypotenuse. So I'm going to take the two legs, 9 and 12. 9 squared plus 12 squared is going to equal the hypotenuse squared, so equal x squared. 9 squared is 81. 12 squared is 144, and that's going to equal x squared. 81 plus 144 is 225, and that equals x squared. If I take the square root then, the square root of 225 is 15, which equals x. You may have gotten to 15 a different way. Maybe you said that 9 times 25 is equal to 225. So then the square root of 9 is 3, and the square root of 25 is 5. 5 times 3 is 15. So when you do the Pythagorean theorem, be careful where you put your x value. You need to pay attention to whether or not x is the hypotenuse for a leg.